हेलो ब्यूटीफुल पीपल। सो आज के वीडियो में हम देखेंगे ऑल अबाउट NumPy एज NumPy इज़ वेरी इंपॉर्टेंट टूल और लाइब्रेरी यू कैन से इन डेटा साइंस. सो इट इज़ वेरी इंपॉर्टेंट टू लर्न और टू have a strong basic understanding of NumPy in Python, and as well as it is used in data science also for computing long and big organization data. So if there is any doubt in the NumPy, you can comment down below. If you are new to this channel, please hit a like button and subscribe to it and share with your friends. Okay, so let's get into it. So as an introduction part, NumPy stands for numerical Python, and it is a core library for numerical computations. Okay, all the computations, all the operations that are accessed on the big organization data is done using Python, and in the Python there is a library called NumPy, numerical Python. It is used for easiness. Okay, providing functionality to make multi-dimensional arrays, 1D, 2D, 3D and n-dimensional arrays. Okay, we have list that we can use to create n-dimensional list instead of using array to perform this task. As you know, if you learn some little bit of Python, you can know the list is very useful for creating n number of elements, and you can say n dimension. Okay, but why we are using NumPy? Okay, what is the basic advantage using NumPy? The advantage of NumPy is memory efficiency, faster and lot of convenience and functionality. The list is some basic data structure. Okay, but NumPy gives us memory efficiency, faster and more convenience and functionality. NumPy is built using C language, which is make easier or much faster. As you know, Python is little bit slower, but NumPy is built in C language, so it is faster. You can see NumPy contains integers, float points and objects. Container like list, dictionary build is faster in mathematical calculation. So that's why NumPy are used in lots of you can say applications in mathematics, data science, Python and lots more. So here are some pictorial form of 1D, 2D and 3D array. Okay, 1D as you can say 0 axis, 2D there is 2 axis 0 and 1, and there are three dimension array which have 0, 1 and 2 axis. You can say what is axis. Axis are the dimensions which are called as axis. And okay, and in 2D array in above picture there are 2 axes, and in 3D array there are 3 axes. In n dimension there are n axes. Okay, so vertically we just name a nomenclature of vertical downwards axis is 0 axis, and horizontal downward axis is 1 axis. So after introduction, let's start by importing a NumPy into our program. So the syntax of importing the NumPy into our program is has a NumPy is a package. Okay, so you have to do import NumPy has np. Np is alias. Okay, you can use np anywhere. You have to use NumPy. Okay, so first of all, let's use this. So NumPy is imported into our program. So first of all, I have said you that NumPy is memory efficiency then list. So let's see one example. Okay, so I have a list. I have created a list of you can say I from range 0 to 100. Okay, so 0 to 100 I have a list, and in MP array I have arranged. I will tell you what is MP dot arrange in next few minutes, but here just NP dot arrange is creating an array of 0 to 100 or 1 to 100 numbers. So MP dot array up to 100 it used to create a number array of 0 1 to 100. Okay, so let me print this. So you can see list as 0 1 2 3 4 up to 99. So it's consume all the memory from 0, it individual memory, 1 individual, 2 individual, 3 individual, so up to 99 it consume lots of memory. And in the array it hold a one package, it holds a single elements, and it stores in a single memory block. Okay, so what is better, list or you can say NumPy? NumPy is better. It's creating an array, it's holding only one block of memory, and it's holding 100 block of memory. So what's the efficiency of array is better than list. Okay, so that's why NumPy is used for betterment of memory efficiency than the list. Okay, next, so the basic idea of creating NumPy is to creating an array. Okay, so we have to creating array. First of all, there are two ways like manually creating NumPy array or by using the function. Okay, functions, and you can say predefined functions. So multiple ways to creating an array. Most common ones are convert list and tuple to array using NumPy np.array. It is a syntax of a function np.array, okay, as done above. So initializing the array using fixed size, or you can say size of your own. So manually creating array, let's suppose I have a list, okay, I have a list and I have to convert it into an array. So what will I do? I will create a variable. I will create a variable and there I will write np.array and you can say list1. Okay, so I convert the list into an array. Okay, so let me print this 1. So you can see it is now a array. Okay, so I will write here also to see, you can see array, and this is the array on you say I want to convert a tuple into array, same procedure. Okay, same procedure you have to follow, that arr, wait a minute, np.array, and what you have to convert is tuple, so tuple 1. Okay, and you write, you can show here, see the tuple is converted into array and the list is converted into array. Now what you want to see, that you have to convert a 2D list into a 2D array. Okay, so you have to convert 2D list into 2D array, that's the same as a list. Okay, so what we will do, arr3, we take a new variable np.array and list, and you can say 2D here because the variable name is 2D. See, you converted this list into an array, the 2D list, 3D list, anything. Okay, so all the things are here, it's the same, you can try same here. So next thing is you have to just know what is the list, or you can say the dimensions or shape of the array. Okay, so let's suppose we have a, okay, we have an array, let's take arr1. So I want to find the shape of arr1 array, so we can write arr dot shape, and for the dimension there is a arr1 dot dimension, or you can say ndim. Okay, so ndim is 1 and shape is 1. Okay, though both let's print this in different form. Print, here you can write dimension, and here you can write, you can say print, and you would write here shape. You can say shape is 8 because we have 8 elements, I guess, 1 2 3 4 5 6 7 8, yes, and the dimension is 1D because it is a one dimension array. You can say it is a one dimension array here. So you know the difference between shape and array, so we can find here very easily. So by using manually, it is very easy to creating an array. Okay, you can convert it here by list, you can convert it the tuple into array, or a 2D list into 2D array. So it is very important, and I will share this IPM file to you and you can try it by your own. So next come is about the creating a 2D array. Okay, so let me show you how to create a 2D array. I am taking a variable arr2d. Okay, and there I will write np.array. Okay, so I have to make a 2D array. Okay, so what is 2D array? It's a, you can say, nested list. Okay, nested array. So I will create a nested array, 1 2 3. Okay, wait, 3. Okay, and next, so this is a one row. 2D have one row and one row down right. Okay, so 5 4 5 and 6. Now let me show you about the output. So you can see we have created a beautiful 2D array. So 1D array is known as vector and 2D array is known as matrix. So you can see it is a matrix of row and column. So there are 2 rows and 3 columns. So 2 into 3 cross matrix is there. So ND array is known as tensor, means n dimension array is known as tensor. This is the some fact. So as we saw some methods of creating manually NumPy array. Now we'll see some functions that will creating an array according to your own needs and some different types of array. Okay, so I am creating a list here of some functions that you should know. These are not all the functions, these are some useful functions that are generally used simultaneously with the help of NumPy, and the computation parts become easy. Okay, so there are some functions like np, ones, zeros, random, arrange, linspace and dinull, and one by one we will see all. Okay, so first of all let's see arrange. Okay, so I am creating an array. Okay, arr, let's suppose arrange. Okay, arr space arr np dot arrange arrange, and I give the 10. Okay, so now let's see the output. So you can see up to 0 to 9 it's creating an array. Okay, now I want some different type of thing like up to 51, 5 to 51, but I want to make a space of 555, like 5, 10, 15. So that's type of array I want to generate. Okay, so how will I do? Okay, so let's see. Arrange. Okay, and I want to start from 5 and to 50. So if I write 50 it will come to 49, so I'll write 51, and I want the space of 5, so I will write here 5, and let's see what's happening here. arr1 ar1. So you can say 5, 10, 15, 20, 25, 30 is a 5 gear up to 50. So you can make any type of things according to your size and according to your space, and all the things is very useful. Not you don't need to write all the elements to, you can use arrange function. Okay, next we can see you can next see about some you can say line space. Okay, creating an array of fixed length. What line space do? Creating an array of fixed length. So we use line space here. Now arr, let's take another variable to np dot line space from let's suppose 0 to 50. Okay, I have again misplaced. Okay, yeah, so let's see. So you can see from 0 to 50 I have created a float values from 0 0.0, 1.2, 2, 3, all the random integers, all the random float values that are coming, and you notice the difference between the arrange and line space, as line space is more precise and more randomized for giving a random or up to the range of the numbers. Okay, you can see 22, 23 up to points decimals is giving. Okay, so one more thing I will show you, that you can also use space here. If I do 10 here, so after some gap of integers like 5, 10, 11, 16 or 5 gap, you can see there is some gap, or you can use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all the 10 things up to 50 you can it use random. Okay, it use random elements here for generating 10. We have given 10 here, so it generate 10. If I give 11 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, it will generate 11 elements. Okay, so up to 0 to 50 it will generate 11 elements in the prescribed float data type. Okay, so this is the difference between arrange and line space. Now next comes about ones. Okay, so let's do arr ar3 np dot ones, and what I have to create here. Okay, that's the basic thing. Ones is creating a matrix, or you can say n dimension array of ones. Okay, there all the elements are 1. So let me create a 5 cross 5 matrix or 5 cross 5 array. So I here do 5 cross 5. Okay, now let's suppose let's see the output. So you can see 5 cross 5 array and 5 dimension array is created, and you can see matrix is created 5 cross 5 of 1, and in the matrix language you can say it is a identity matrix. No, identity matrix is diagonally 1 and all the rest are 0. So that's a different thing, and all the ones are ones matrix. Okay, now I don't want the float value. So what we'll do, this we do comma d type is equals to int. So you can say all the elements are converted into the integer. I can use here also. Okay, I can use here like d type is equals to int. You can see all I can convert it into integer. Okay, same as 0, we can use same as 0 function 0 like arr4 okay np dot zeros, and I same created 5 cross 5 and arr4, you can say the matrix becomes of 0. Okay, so once zeros arrange space all are covered. Now let's see about, okay, additionally I keep you with this. There is one more function known as full. Okay, full creates any integer with the whole matrix. Okay, you can see all the integers with 5. You can fill all the elements with 4, any integer. Okay, let's see np dot full. Same syntax is same. 5 cross 5 or 6 cross 6, you can use anything. Okay, and I will use you can say 8. See, all the elements become 8. So 0, 1s and full, these all are same, but the difference is 0 is for zeros element, 1 is for filling all the elements to 1, and full is creating your own any integer element. Okay, so let me do. Now what's left behind is we have covered the ones, zeros, arrange lineups, and let's see about diagonals. Okay, here diagonal, construct a diagonal array. So I want to create a diagonal array. What do you mean by diagonal array? The diagonal elements are integers, non-zeros, and the rest are zeros. Okay, so let's create a diagonal array np dot diag. Okay, so I want to create a diagonal array. So let's suppose 2, 3, 4, 5. So these are the elements I have to put into the diagonals of the array. Okay, so it will take automatically according to the logic. Okay, so you say it is I have put the 5 elements and it gives a 5 cross 5 diagonal array. It is n dimensional array, you can say 5 cross 5 matrix. Okay, so this is the diagonal function of a np array. Now let's use a random. Okay, we have covered ones, zeros, arrange lines by diagonal, and last not the least np dot random. So let's use np dot random here. Np dot random dot random, it is very useful function. Okay, I create a 5 cross 5 n dimension array. Here is the full thing, that it's creating a random number of floats, and if you want to switch here, d type is equals to integer. See, random does not expected keyword d type, so we don't have a data type conversion here, but we can use another method for converting into data type. Let me show you. So by default it takes a random integer from 5 cross 5, or you can say we have to just give the size and it will create a array of random numbers. But what if I want to create a random matrix, or you can say array of integer? That's also a very good part, as let me show you. Np dot random dot rand int. Okay, so this is the function rand int, right? Okay, 5 to 100. Okay, 5 to 100. I want to create a random integer 5 to 100, or you can see the in the random integer I will give the range. Okay, like 5 to 100, all the between the range I have to create an array. and 8. Wait, there is some mistake here. Okay, naming mistake again. So see, 9. Okay, 98, again I press 9. 26, again I press 94, again I press 68. But which one, where is the array? It's giving a single integer. So what I will do, I want some you can say 6 elements array. So I'll give here 6. Now you can see I have a 6 element array. If I want 7 random integer array up to from 5 to 100, the function is yours. From 85 to 90, it gives a random array of numbers. Okay, so this is the very useful and important function of creating a random array from the given to range of the given size. Okay, so this all about the random, all the functions. Here you can use the functions with the basic things, and I will share you this file. You can also practice here by seeing this. After the creating an array, or by creating the array using both methods like manually and functions by using function like arrange, line space, diagonals, ones, zeros, all these things. Now we'll come to the basic data types of the NumPy. So there are basic NumPy's array. You can see data types like integer, float, and these all are the NumPy's data types, and you can use like increment, complex, boolean. These all are data types which are more you can say not often used, but yes, use, and you should know about this. So let's start from a float. Okay, so float is a data type of NumPy, or you can say Python. So let's create a float. Let's create a float array. Okay, by using np.arrange. I want some 15 up to start from 0 to 15, and the data type should be float. So here it is an array of 0, 1, 2, 3, and its data type is float. Now let's see about the integer type. So I want to create an integer type, you can say array, or you can use same here also. Okay, and I'll do here int, and let's change this to integer, and let's see the output. So you can see, and I can also use the predefined function as I used above, like once. Okay, I want to create a once array, so np.once. Okay, I want to create a 3x3 matrix, right? And I'll create the data type of int a1. So you can see we have a data type of integer and the ones. So these are the basic things you should know, and I think you know all these things. Now let's see some complex, or you can say some different data types which you have seen but not often used in your day-to-day life. Okay, so let's take a variable, an np.array. So I want to create an array of complex number iota. Okay, so what I'll do, I create an array 1 plus 2j, right, and 2 plus 4j. This is the, you can say iota j, anything. If I print d, you can see this is the complex number, or should I show you, I'll print d dot d type. That will give you, see, it is a complex number. Okay, I haven't print the number, it is not a string, it is a data type, it is a complex integer. Okay, next you can store boolean also. Okay, let's store boolean. So np.array, let's store true, false, true, b. So this is array of true false, and I'll show you the d type, it's bool. Okay, So boolean data type is also stored in an array. It's not only for integers and float. Now let's talk about string. Okay, np.array. Yeah, it's more often, and you will use more oftenly this, like Ram, Harry, hello, okay, vs, and you can see is an array, and okay, and if I type the type, and it's showing me an string. Okay, it is a string, which is string array, which is denoted by this. So this all the things like basic data types and creating an array, and we see the introduction of what is matrices and what are the nomenclature we use in the matrix, how to import matrix, memory composition. We have comparison of memory of between list and Python and NumPy, creating a NumPy array by using two methods manually, by converting list into tuple also, and by creating 2D array, by creating an array using functions like arrange, ones. Now in next video, let's talk about the indexing and slicing and the NumPy numerical operations.